So I want to talk about an application of conditional probability, and it has to do, again, with, let's go back to what we saw with multiplication. So we saw earlier that the probability of A and B is equal to the probability of A times the probability of B given that A has occurred. And so that was our multiplication formula. Now, typically what we can do is we can divide both sides of this equation by the probability of A, and we're going to get this. So if we know the probability of A and B, now remember what this means. These are the number of outcomes that are in event A and also in event B, divided by the number of outcomes in event A. That's how we come up with the probability of B given A. So, for example, let's say we have this. Do our Venn diagrams. So what we saw before is the probability of B given that A has occurred. Now what this means, again, is we take our sample space, shrink it down to event A only. So we go from 9 outcomes total, the 4 here, there's 2 more, then there's 3. We're going to shrink down to just these 4. And it turns out one of these is still part of B. So a little bit of B sort of survives this shrinking down to, the sample space shrinking down to just A. So the probability of B, given that we're only considering outcomes that are in A, well, there's one that's also still in B. So there's 4 that are in A, and one of them also happens to be in B. So it's 1/4. So what this says is the probability of A and B. Well, the probability of A and B. So these are outcomes that are in both A and B. Well, there's only 1 out of the 9. So there we go. Probability of A, how many outcomes are in A? It's going to be 4/9. And so let's use our formula. Take the probability of A and B and divide by A. So what do we get? Well, we'll get 1/9 divided by 4/9, and sure enough, this will come out to 1/4, as we would want. All right. So that's an application of conditional probability. Now let me go over an example in the text. Now, in New Mexico, marijuana is legal if you're 21 and over. And there's some more details to that. Now, let's say, though, you're applying for a job. And nonetheless, you need to pass a drug test. So this is a question that we're looking at in the text. So we're going to select one person out of 555. And these are 555 test subjects. And what we're going to do is we want to figure out the probability that you will get a positive drug test given that you say you smoke some marijuana. So So it's legal in the state of New Mexico, 21 and over. And all right, so you're applying for a job and you want to, well, this job still requires that you need to be sober, and they don't want you using any drugs. So let's say someone did do some drugs, they smoked some marijuana, and they're wondering, well, what's the probability of me showing up positive? Now, this might seem kind of strange. It's like, well, wouldn't it be guaranteed? Well, it turns out it isn't. Some of these tests, for example, you could smoke marijuana and it could still come back with a negative test. So it depends, if you're an employee, it's something there you go. You can, whether you're going to test positive or not. If you're an employer, this could be a big consideration as well. If this is a job where you really need people not to be, you need them clear thinking, and you're going to use this drug test to make sure people are showing up to work sober. What are the odds of this thing working or not working? So let's take a look. So there's some data. This is an example in the text, and they give us some information here. So let's say we do know this. The probability of someone using drugs and having a positive test. So in this group of 555 people, say positive and drugs. So of these 55 people, there were 45 who had done drugs, had a positive test with having done drugs. And the two just go together. There were 45 people where that was the case. Now, of this 555, there are 50 who use marijuana and say it's marijuana. So we want to figure out this. The probability of a positive test given first somebody was smoking marijuana. So we have data that says we have 45 people who have positive tests having smoked marijuana. We have 50 people who have smoked marijuana. So what's the probability of getting a positive test after smoking marijuana? Now, this might seem like a strange question. I mean, wouldn't it sort of be this? And it's like, well, let's take a look here. 50 people were smoking marijuana, 45 were smoking marijuana, and at the same time had a positive test. So these two numbers are not the same, the 50 and the 45. So that's what we're looking at. Looks like, all right, not everyone who's smoking marijuana is testing positive. So now we're going to ask that question. So what's the probability that you're going to test positive if you have smoked marijuana? And so we take the probability of being positive and having smoked marijuana divided by the probability that, well, someone smoked marijuana. And you'll get 45 out of 50, or this comes out to 9/10, or 0.900. So that's 90%. That's pretty high, actually. So there's a 90, based on these numbers, if you smoked marijuana, the tests that they're using, say at this job site, there's a 90% chance it's going to figure it out. So again, if you're an employee, that's what you got. If you're an employer, you might ask, well, is that a high enough threshold? Is 90% of the time good enough? And again, that's something they would have to answer. So that's just an example with working with conditional probabilities and just a little application with those and multiplication. So any questions? Let me know.